I wanted to put something together in order to try and visualize the thoughts that I'm having with respect to this concept of centrifugal force and centripetal force with respect to the turns performed in skiing. If you look at a diagram found on the internet, you will see labels on a turning skier with a gray arrow for the force of weight, a green arrow for the turning force, and then a large red arrow labeled as the resultant force. Coming from a physics background, I look at the turning or G force as it is labeled in this diagram and wonder where it is coming from. We are taught through Newton's third law the concept of action-reaction, which here I have labeled with a yellow arrow as the reaction to the force of the snow pushing up on the skis. If through vector addition we add the yellow arrow to the gray arrow, we would come up with a resultant force which here I represent with a blue arrow. This is the net force and direction in a turn and can be illustrated using the two interactions of gravity and the push of the snow. In this diagram, reading from the top, we have the net force, or F sub net, is proportional to acceleration, which just states that if there is a surplus of force, then acceleration will happen in that direction. This then leads to a statement of Newton's second law, which simply states that if there is a net force, then there will be a subsequent acceleration. In the realm of circular motion, the equation then becomes F sub c, or force centripetal, is equal to mass times the centripetal acceleration, which is in turn equal to mass times the velocity squared over the radius with which the object is turning. Below you can see a diagram of a ski turn and the radius of the turn, r. Here we have a simplified diagram, a free body diagram of the center of mass, cm, of the skier, and the supposedly three forces acting on her. The force of weight, F sub w, the turning force. Where is this coming from? Is this the centrifugal force that often is referred to? And then a resultant. The problem that I see with this argument is that the resultant is questionable due to the fact that you are basing it on the assumption of a centrifugal force. Forces are single interactions between two objects according to Newton's third law. The weight is due to the interaction between the skier and the earth. The centrifugal is... The normal or perpendicular force is the interaction between the skis and the snow. It is this combination between the normal force and the weight force that lead to the centripetal acceleration of the skier into the turn. Here's a closer look at the cm of the hips of the skier. You can see the 5 arrows, and the two that I want you to focus on are the yellow arrow, which represents the force of the snow pushing up on the skier, and the gray arrow, which represents the earth pulling down on the skier's center of mass. Through graphical or mathematical means, you can add these two forces and you will get the blue arrow, or the centripetal force acting towards the inside of the turn. I have labeled the turning force, the green arrow, as not a force. In closing, I have one more diagram. If one thinks of a ball of clay being swung around on the end of a piece of string, and in this view you are looking down on this situation, imagine as the ball is swinging around in a circle that the string is instantaneously cut. In what direction will the now free ball fly? Well, it will fly off in a straight line path. It does not fly directly away from the center. In fact, there is no force making it fly straight off. The force of the string was providing centripetal acceleration towards the center, and now that it is no longer present, there is no reason for the ball to turn. Centrifugal force is not necessary in this explanation. Thank you for watching.